Welcome back. We are on the topic modular arithmetic. In the previous video, we learned how to draw a table for an operation in a given modulus. In this video, we are going to solve a question on drawing tables for an operation in a given modulus. The question for this video is, draw a multiplication table for mode 6. We learned in the previous video that when you are asked to draw a table for an operation in a given modulus, the first thing you have to do is to define the set of values in that modulus. Here, we are being asked to draw a multiplication table for mode 6. So the first thing you do is to define the set of values used in mode 6. The set of values used in mode 6 are 0, 1, 2, 3, 4, 5. After we have defined the set of values, the next thing we have to do is to use this set of values to draw the table. We have 6 values in total, so we are going to draw a table with 7 columns and 7 rows. In the first cell of the table, you write the sign of the operation you are going to perform. We are going to draw a multiplication table, so the operation is multiplication. In the first cell of the table, you write the multiplication sign, then you draw a circle around it. Then you list the set of values in the first row and the first column, just as we have in this table. After you have drawn the table like this, you fill it out by performing the operation in the modulus. The operation is multiplication, and the modulus is 6. So we are going to multiply these numbers in mode 6. The first one is 0 times 0. 0 times 0 is 0. 0 in mode 6 is 0. So we have 0 here. 0 times 1 is 0. 0 in mode 6 is 0. 0 times 2 is 0. 0 in mode 6 is 0. 0 times 3 is 0. 0 in mode 6 is 0. 0 times 4 is 0. 0 in mode 6 is 0. And 0 times 5 is 0. 0 in mode 6 is 0. So in the first row, all the numbers are 0. Let's move on to the next row. 1 times 0 is 0. 0 in mode 6 is 0. 1 times 1 is 1. 1 in mode 6 is 1. 1 times 2 is 2. 2 in mode 6 is 2. 1 times 3 is 3. 3 in mode 6 is 3. 1 times 4 is 4. 4 in mode 6 is 4. 1 times 5 is 5. 5 in mode 6 is 5. Let's move on to the next row. 2 times 0 is 0. 0 in mode 6 is 0. 2 times 1 is 2. 2 in mode 6 is 2. 2 times 2 is 4. 4 in mode 6 is 4. 2 times 3 is 6. 6 in mode 6 is 0. 2 times 4 is 8. 8 in mode 6 is 2. 2 times 5 is 10. 10 mode 6 is 4. Let's move on to the next row. We have 3 times 0. 3 times 0 is 0. 0 mode 6 is 0. 3 times 1 is 3. 3 mode 6 is 3. 3 times 2 is 6. 6 mode 6 is 0. 3 times 3 is 9. 9 mode 6 is 3. 3 times 4 is 12. 12 mode 6 is 0 because 12 divided by 6 will give us 2 remainder 0. So you write the remainder. So 12 mode 6 is 0. 3 times 5 is 15. 15 mode 6 is 3. You divide 15 by 6, you have 2 remainder 3. So 15 mode 6 is 3. Let's move on to the next row. 4 times 0 is 0. 0 mode 6 is 6. 4 times 1 is 4. 4 mode 6 is 4. 4 times 2 is 8. 8 mode 6 is 2. 4 times 3 is 12. 12 mode 6 is 0. 4 times 4 is 16. 16 mode 6 is 4. 4 times 5 is 20. 20 mod 6 is 2 because 20 divided by 6 will give us 3 remainder 2. Let's move on to the last row. We have 5 times 0. 5 times 0 is 0. 0 mod 6 is 6. 5 times 1 is 5. 5 mod 6 is 5. 5 times 2 is 10. 10 mod 6 is 4. 5 times 3 is 15. 15 mod 6 is 3. 5 times 4 is 20. 20 mod 6 is 2. And finally, 5 times 5 is 25. 25 mod 6 is 1 because 25 divided by 6 will give us 4 remainder 1. I'm going to show you a very simple trick that you can use to find a value when the number is bigger than the modulus. So for example, when you have 25 mod 6, we can see that 25, which is the number, is bigger than 6, which is the modulus. I'm going to show you a trick that you can use. You subtract the modulus from the number and you keep on subtracting until you get a number that is less than the modulus. This is what I mean. You want to find 25 mod 6. You search on your calculator. Subtract 6 from 25. So you have 25 minus 6. This will give us 19. 19 is bigger than the modulus, which is 6. So you subtract 6 from 19 again. So 19 minus 6. And that will give us 13. 13 is still bigger than the modulus, which is 6. So you subtract 6 again. 13 minus 6 will give us 7. 7 is still bigger than the modulus, which is 6. So you subtract 6 again and you have 1. Now, 1 is less than the modulus, which is 6. So it means that 25 mod 6 is 1. Let's try for another example. Let's say 20 mod 6. So we are going to subtract 6 from 20 until we get a number that is less than 6. So you have 20 minus 6. 20 minus 6 will give us 14. 14 is not less than 6. So you subtract 6 from 14. 14 minus 6 will give us 8. 8 is still not less than 6. So you subtract 6 from it again. 8 minus 6, as we all know, will give us 2. So we can see that 20 mod 6 will give us 2. Let's try for another example. Let's say 15 mod 6. 15 mod 6. So you subtract 6 from 15 until you get a number that is less than 6. You have 15 minus 6, and that will give us 9. 9 is not less than 6, so you subtract 6 from it again. 9 minus 6, as you all know, you have 3. So it means that 15 mod 6 will give us 3. Let's try for 10 mod 6. 10 is bigger than the modulus. 10 is the number and 6 is the modulus. And you can see that 10 is bigger than 6. So to find 10 mod 6, if you want to use this trick, all you have to do is to subtract 6 from 10. 10 minus 6 will give us 4. 4 is less than 6, so it means that 10 mod 6 is 4. So when the number is bigger than the modulus, you can use this simple trick to find the value of that number in the modulus. You subtract the modulus from the number until you get a value that is smaller than the modulus. This trick can be very helpful when you are drawing addition and multiplication tables in modular arithmetic. Let's go back to our question. So we have now completed the multiplication table for mod 6. Thank you for watching this video. Subscribe to this channel for more videos. In the two examples that we have considered so far, that is the example in the previous video and the one in this video, we were asked to draw an addition table or multiplication table for a particular modulus. So we defined a set of values in that modulus and we used it to draw the table. Sometimes the set of values that you are going to use to draw the table will be defined for you. In the next video, we are going to solve a question on drawing a table for an operation in a given modulus when the set of values have been defined for you. Bye-bye.